In this video, we'll learn how to set up process optimization using Chemkin-Pro and Ansys Workbench. There are two parts to this process. First, we'll set up Ansys Workbench and use Chemkin-Pro reactor in it. For the example, we're going to use a perfectly stirred reactor model in Chemkin-Pro, and the process we are trying to simulate is chemical vapor deposition of silicon nitride. In the setup, we have the stream coming in, and it's a mixture of silicon tetrafluoride and ammonia. There is a reaction occurring in the gas phase as well as surface, and the surface deposition occurs on the reactor walls, as you can see from this cartoon. So let's switch to Ansys Workbench and set up the simulation. We'll open Ansys Workbench and load Chemkin component system. You can double click on it, go to the setup, and if you right click, you can import a Chemkin project right from here. Or if you double click on this, it's going to open a Chemkin user interface. Let me arrange them side by side. For the example today, I'm going to import a pre-made sample project that comes with the installation. We'll browse to PSR_CVD and load the project here. So you can look at the reaction diagram view, and you can see PSR reactor setup here. If you go to pre-processing panel, you'll be able to see the details of the kinetic model used in the simulation. Here I'm going to use total 4 control parameters. First, reactor temperature, as you can see on this panel. If I click on this button, it will send this parameter as a control to reaction from Chemkin to Ansys Workbench. And as you can see, once I click on it, it adds this parameter set and line to Chemkin block. The second, I'm going to use flow rate as another control parameter. Same thing, click on this button. I'll use initial or inlet composition as another set of control parameter. So if I click on this one, and I'm going to type in the name of the chemical, it's silicon tetrafluoride, and I'll also use ammonia as composition one. Next, I would like to see what kind of target that I want to achieve in this optimization. So we go to Analyze Results, and then select the output that we want to send back to Ansys Workbench. Here, let's select one of the bulk growth rate. As you can see, we can pick either bulk 1 or bulk 2. One is for silicon, other for nitrogen on the surface. So we apply update, and that's all we need to do in order to set up Chemkin and access it from Ansys Workbench. Part 2 of the setup is to actually use any of the optimizer in Ansys Workbench and run the optimization process. So let's look at that. There are several optimizers included with Ansys Workbench: direct optimization, response surface optimization, and OptiSlang. We're going to use response surface optimization, so I'll double click on that, and it will add a block here. Here you can create design of experiments using the parameters that you like, or use the default setting that comes with it. I'm going to go with the default and set up an objective in optimization. For objective, the parameter I'm going to use is growth rate for the bulk deposition, and we would like to maximize the growth rate. So I set the maximize. That is all you need to do in order to set up simulation. And then I'm going to click Project Update. As soon as you click on it, the runs start in the background, and you can look at the process here. I'll let it run, and let me show you the results. If you double click on Design of Experiments, you will be able to see there are 25 different or additional runs created in Design of Experiments. If you go to Optimization Results, we'll be able to see several results including trade-off, where you can see which parameter has what kind of impact on the target. You can also look at sensitivity, and you can see here that temperature and flow rate appears to have larger sensitivity on deposition or the growth rate than the initial composition.